Hello students, myself Dr. Rachna Pathak, Assistant Professor in Faculty of Engineering and Technology, University of Lucknow. The topic of today's lecture is Center of Gravity, Constant and Variable Densities. In this lecture, we find the coordinates of center of gravity with the help of double integration. So, we go through the formula what the center of gravity. If x bar y bar is the required center of gravity, then the equation can be written as x bar double integration rho x dx dy upon double integration rho dx dy, where rho is the density, rho may be constant and may be variable, and y bar can be written as double integration rho y dx dy upon double integration rho dx dy. This is in the form of Cartesian. We can also written as in the polar coordinates. We replace x equal to r cos theta, y is equal to r sin theta, and dx dy is can written as r dr d theta. So, put the values here in the Cartesian form, double integration rho x equal to r cos theta, and in the place of dx dy is r dr d theta upon double integration rho r dr d theta, and y bar can be written as double integration rho y is r sin theta, dx dy is equal to r dr d theta upon double integration rho r dr d theta in the polar coordinates. So, we solve the example based of center of gravity. The example goes to the center of mass and also center of gravity. A triangular thin plate with vertices 0, 0, 2, 0 and 2, 4 has density rho is equal to 1 plus x plus y. Here density of function of x, y, so is the variable density. Then find the mass of the plate and the position of center of gravity of G. So, solving such like equation, we firstly know what is a double integration, how to find the area with the help of double integration. If we know about double integration and the application of double integration, we can solve such like example. So, firstly we draw the figure for with given conditions. Here condition vertices given 0, 0. So, first point is here 0, 0, 2, 0, 2, 0 is here and 2, 4. Join these points, we get this triangular theme 0 A B O is an enclosed curve, and find the area of this curve. We have the condition is mass of the plate. We know that what is the mass? M is the product of area into density. Find the area with the help of double integration, such like double integration dx dy and multiply by density. What is density? Density is rho x plus x y. So, firstly find the area. We have the choice, draw the strip parallel to the y axis, draw strip parallel to the x axis. So, we see here both. If we draw and the first and before going to the draw the strip parallel to the y axis, because here given only points, not the equation of line. So, firstly find the equation of line. Here we see that there are 0, 0, 2, 0 and 1. What is the equation of this line? Here write to y is equal to 2x, and how to find this? Here the equation of line is y is equal to 0. We know that there is the x axis, the line of equation x axis is y is equal to 0. This is obvious, but how to write the equation y is equal to 2x? Here is the 2 points 0, 0, 2, 4. We know that if have 2 points, we have the equation of the two points. What is this? Y minus y1 is equal to y2 minus y1 upon x2 minus x1 and x minus x1. Here y1 is 0, that means y comma 0 is equal to y2 is 4 minus 0, x2 is 2 minus 0 and x1 minus 0, and solve this question we get y is equal to 2x. So, equation of this OB is y is equal to 2x and OA is y is equal to 0, and we draw the strip parallel to the y axis for the finding of this triangular plate. So, what is the limit for y? The limits of y 0 to 2x, and what is the limit of x is 0 to 2. The x is 0 to 2 and the y limits is 0 to 2x. So, we put the limits, what is 0 to 2 and 0 to 2x. The value of rho is given is 1 plus x plus y dy dx. There is an integration in the function. We can say that here the limit in the function of x. So, integrate with respect to y firstly. So, we integrate 1 plus x, x here is the constant, 1 plus x y plus y square by 2 and put the limit 0 to 2x and solve it. We have 0 to 2, 2x plus 4x square ds. Here function in the form of x. So, integrate this integration with respect to x, x square plus 4 by 3 x cube and put the value 0 to 2. 44 by 3 is the mass of the given curve. Okay. And we goes to the next part of this question. What is say? Find the coordinates of the center of gravity. We know that what is the value of x bar? X bar double integration rho dx dx dy upon m, because here in the formula we can write this x bar is equal to double integration rho dx dy upon double integration rho dx dy. This is mass of lamina, is also represented at m. So, we put here double integration rho x dx upon dy upon m and put the value of m is 44 by 3. So, 3 by 44 and limits go to 0 to 2x and rho is 1 plus x plus y x dy dx. The limit in the function of x. So, integrate this integration with respect to y is 2x plus 4x square x dx, and after this the function is the x only. So, integrate this integration with respect to x and put the limits, we get the coordinate of x bar is 16 by 11. Now, we find the coordinate of y bar is y bar is equal to double integration rho y dx dy upon m. We know the value of m, what is 44 by 3, put here and put the limits 0 to 2, 0 to 2x, rho is 1 plus x plus y dy dx. Here the limit of function of x. So, integrate this integration with respect to y firstly is 3 by 44, 0 to 2, 1 plus x y square by 2 plus y cube by 3 and 0 to x is the limit, put here is 3 by 44 is 0 to 1 plus x 2x square plus 8 by 3 x cube dx. This function is x only. So, integrate this integration with respect to x and put the limit 0 to, we get 18 by 11. So, center of gravity is x bar, y value is 16 by 11 x coordinate and 18 by 11 is y coordinate. So, center of gravity is 16 by 11 comma 18 by 11. And now, we go to the next example of this. Find the position of center of gravity of a semicircular lamina of radius a if its density varies as the square of the distance from the diameter. Firstly, we draw the figure for such like example, because without drawing the figure we cannot find the coordinates. So, let the bonding diameter be the x axis and a line perpendicular to the diameter passing through the center is y axis. Center passing to the y axis, that means center of gravity lie on the y axis. If center lie on the y axis, that the coordinate of x bar is 0. Equation of circle is x square y square to a square, and by symmetry you can say that x bar is equal to 0. This is the figure of the semicircular. There we said as we have G lie on the y axis. So, coordinate of x bar is 0 and this is y bar only. Here we only the value of y bar because x bar is 0. For solving such like equation, firstly always write the formula. What is the formula of x bar is? Double integration rho x dx dy upon double integration rho dx dy, and y bar is equal to double integration rho y dx dy upon double integration rho dx dy. So, x bar is 0 and find the value of y bar. Here density is proportional to diameter, is rho is equal to proportional to y square, rho is equal to k y square. So, put the values in the equation. In y bar is equal to double integration y rho dx dy upon rho dx dy. What the value of rho is? Lambda y square. A double integration y lambda y square dx dy upon double integration lambda y square dx dy, and put the limits. How to find the limit? There we put the values of rho, that means density, and dx dy, and how to find the limits. We goes to again the figure here. The way you have the formula is, what the cycle formula is, x square y square is equal to a square. Okay. Y square to a square minus x square, y is equal to plus minus under root a square minus x square. From figure we can see that the equation, if we draw the strip parallel to y axis, that means 0 to, this is 0 to this curve, this curve to goes to positive coordinate only, y is equal to under root a square minus x square. But where x axis is, that is a, this is minus a. How to find this? If the cycle equation is this, put y is equal to 0 here, x square to a square, x square to plus minus a. So, the x varies from minus a to a and y varies to 0 to under root a square y square. So, put the limits here, minus a to a dx 0 to under root a square minus x square y cube dy upon minus a to a dx 0 to under root a square minus x square y square dy. There is a limit in the function of x. So, integrate this integration with respect to y firstly, that means y cube power 4 by 4, and put the limits, and 0 minus a to a dx y cube by 3 and put the limits. So, we get the 3 minus a to a square minus x square dx, and 4 times minus a to a square minus x square की power 3 by 2 dx. The equation is this, but this solve the integration is not easy. So, we change, put by x square to a sin theta. If put x square to a sin theta, that means dx square to a cos theta, and also change the limit. Here limit is minus a, and also said that here is a limit, that is a minus a is a sin theta, that is sin theta is equal to minus 1, and a is equal to, that is sin theta is 1. What is the value of theta is 1 and minus 1? We know that sin pi by 2 is 1 and minus, that means pi minus pi by 2 is minus 1. So, put here the values of the limits is 3 times minus pi by 2 is pi by 2, and x square is equal to a sin square theta, and solve with dx is equal to a cos theta. Put we have a की power 5 cos की power 5 theta d theta upon 4 times minus 4 by 2 4 pi by 2 a power 4 cos 4 theta d theta. For solving such like integration, we use gamma function. We know the formula of the sin 5 sin a theta because b theta in the gamma form. Use them and solve the integration and find the result, which is 32 a upon 15 pi. We know that the x bar is 0. So, coordinate of center of gravity is 0 comma 32 a upon 15 pi. We next go to the next example. Find the center of gravity of the area in the positive coordinates of the curve. What the curve is? S की power 2 by 3 y plus y की power 2 by 3 is equal to a की power 2 by 3. Firstly, write the equation of center of gravity. What is the x bar? X bar is double integration x dx dy upon double integration dx dy here, and y bar is equal to double integration y dx dy upon double integration dx dy. In the example we can see here that center of gravity here x, the integration dx dy here constant rho is 1. With the in the first slide we write the formula in the rho, we using the rho in the center of gravity, but here the density is 1. So, we write 1 at the place of rho. The coordinate of x bar is double integration x dx dy upon double integration dx dy, and y bar is equal to double integration y dx dy upon double integration dx dy. And what is the limit corresponding to x and y? So, using the coordinate equation, this is a equation of the curve, and the y is equal to y 2 by 3 is equal to a by 2 by 3 minus x की power 2 by 3 is y is equal to a 2 by 3 minus x की power 2 by 3 power 3 by 2, and the only first coordinate is goes to 0 to a by 2 by 3 minus x की power 2 by 3 3 by 2, and find the limits from the x. So, put y is equal to 0 here, we have x की power 2 by 3 is equal to a की power 2 by 3 x is equal to a. So, limits goes to 0 to a x dx, 0 to a by 2 by 3 minus x की power 2 by 3 power 3 by 2. Here the limits in the function of x. So, integrate this integration with respect to y firstly and put the limits, and then we have the only function of x. So, integrate with respect to x. So, we integrate this integration with respect to y, we have this equation 0 to a x dx, and put the value limits, we have the x, and solving such like integration we use substitution method and put x is equal to a cos cube theta, that means dx is equal to a 3 cos theta is cos square theta minus sin theta. Put in the equation and also change the limit. How to change the limit? We have the form, what is the limit? 0 to a, because we change in only x form. If x equal to 0, cos what value of 0? We know that theta pi by 2 is 0. So, pi by 2, theta is lower limit is pi by 2, and a, put a is 1. What is value of cos theta is 1 at 0. Theta is 0, the value of 1 is theta is 1. So, limits goes to pi by 2 a, and put the value of x equal to a sin cos cube theta and solve this equation 0, and also changing the order with the help of the properties of integrations. We have the finally we get the integration 0 to pi by 2 sin power 4 theta cos 5 theta d theta upon 0 pi by 2 sin 4 theta cos square theta d theta, and with the help of gamma function solve this integration, and finally find the solution is 256 a 315 pi. This is the equation, this is a value of x bar. We also find a value of y bar. In the similar process, y bar is some integration y dx dy upon double integration dx dy, and put the limits in the equation. We have find the same value of y bar also. So, the center of gravity of area is 256 a upon 315 pi and 256 a upon 315 pi. This is the required result of the given equation. And now goes to the last example of this lecture. Find the double integration, find by the double integration the center of gravity of area of the chordioid. Chordioid equation is r is equal to a 1 plus cos theta. Firstly, draw the figure of chordioid. The figure of chordioid is such like, and we let assume x bar y bar center of gravity of this chordioid. What the value of x bar y bar? The x bar is the y bar on the x axis, so coordinate center of gravity lies on the x axis, the coordinates of y bar is 0. So, only find the value of x bar here. What is the value of x bar? X bar is equal to double integration x dx dy upon double integration dx dy, and now find the limits of r and theta, because in the polar coordinates. So, while value of the limits in also in the polar, we have r square to, what the value is, r square to a 1 plus cos theta. Okay. This is the coordinate, and the values of the pi is, what the values of pi is, and r coordinates. If put r is equal to 0, if the equation put r equal to, r is equal to 0, what is the value of r is equal to 0 to a 1 plus cos theta, and the coordinates of theta is minus pi to pi. If put r is equal to 0, we have 1 plus cos theta is equal to 0, that means cos theta is equal to minus 1, that is the value of is equal to minus pi to pi. So, limits of theta is minus pi to pi, and range of r is 0 to r 1 a plus cos theta, and x is equal to, what is the x in the polar form, x is equal to r cos theta and y is equal to r sin theta. Here we use only x. So, put the value of x is r cos theta, dx dy is equal to r d theta dr upon minus pi to pi 0 a 1 plus cos theta r d theta dr. So, there is a limit in the theta form. So, integrate with respect to r firstly. So, we integrate for r cube by 3 and put the value 0 to a 1 plus cos theta and upon r square by 2 0 to a plus 1 cos theta. Put the limits, we have minus pi to pi cos theta d theta a cube by 3 1 plus cos theta cube, and solving these integrations, we are putting the values of cos theta in the form of cos square theta by 2 and integrate with respect to theta and put the limits, we get 5a by 24 is value of x bar. The value of x bar is 50a upon 24 and y bar is 0. So, center of gravity of this coordinate is, so it 5a upon 24 comma 0. So, in this lecture we will study how to find the center of gravity of the given curve and with the help of double integration. For solving this type of equation, we know how to use double integration, how to find the area of with the help of double integration, and how to draw the strip on the x axis parallel to the x axis, parallel to the y axis, and what is the coordinate of the center of gravity in the form of double integrations in Cartesian form and polar form. After knowing this, we can solve such like examples.